All right, welcome to lesson 4, Under Pressure, Raining Down on Me, if you know the song. Here we're going to learn to express the relationship between pressure, force, and area to compare the effectiveness of different sized seatbelts. So what is pressure? We're going to define it, we're going to find the formula for it, and we're going to look at some examples of it. All right, so here's a little GIF where these candles will experience pressure. It's always fun. So the amount of force divided by the area it is applied to. Remember, area is a two-dimensional space. Length times width. Like your paper has an area, right? And in the example above, at first the pressure's spread across the entire area of the candles, and then it gets concentrated into those holes, which is why we get that fun little confetti situation. So, formula for pressure. Pressure is force divided by area, or P equals F divided by A. The divisor, that is the thing being divided, here it's force, in the quotient. The quotient is pressure. Divisor's area, pardon me. Divisor's area, quotient is pressure. They are indirectly proportional. It means when you have more area, there's less pressure for the same amount of force, and if there's less area, there's more pressure. That kind of makes sense. If you poke something like this, you feel a stronger poke in that one little spot than if you put your hands together with the same amount of force, the amount of pushing. All right. Now also, force equals pressure times area, and I kind of just described. And the area can be found from the pressure over the by the pressure divided by force, though you almost never use that version of the formula. Oh, what's this? Something's weird's going on. That's crazy. Ignore that slide. All right, so we got an example here. The guy hanging out on a nail bed. So one nail, very small, and therefore even a small force can apply a large pressure. Okay, but if there's a lot of nails together, they have a large area, and therefore even a large force could apply small pressure. So this guy laying on this is fine, whereas like I talked about a few weeks ago, if you stepped on one nail, it'd go right through you. In other words, small nail apply big force pressure even with small force, but much nails divide big force across big area, if you want to say it funny and silly. Okay, so here's a math example. So we can kind of see this with math now. So a force of 35 newtons is applied over an area of 7 meters squared. What's the pressure? Okay, and area is squared because you're multiplying two things together, okay? So P equals F divided by A. So if the force is 35 newtons, force F, 35. Area is 7 meters squared. Area A, 7. 35 divided by 7 equals 5 newtons per meter. Basically, the idea being that those 35 newtons got spread across the 7 meters, square meters, I should say. So there's 5 newtons per square meter. Okay. Here's the pro version where we write it all fancy. Okay, a force of 35 newtons, that's how we write it, fancy, much shorter, easier, faster, is applied over an area of 7 meters squared. What's the pressure? So P equals F divided by A, P equals 35N divided by 7M squared. In physics, we often write our variables in parentheses because there's a lot of units and things like this floating around, so it makes it a lot easier to keep this straight in your head. And we get 5 newtons per meter.